my screen now?
Yes, and it's in presentation mode.
Great, great. Okay, so I'm going to give a, well, building on what Jim has just said, I'm going to give a brief introduction to DAFNI, what we're trying to do, and what we have. You know, I think Jim's given great context there, but try and give a little bit more on that. So I'm Brian Matthews. I'm the project lead for the DAFNI development and hosting team, which is based at the Scientific Computing Department at the Science and Technologies Facilities Council. I'll explain a little bit about who we are a little bit later. And yeah, so I'll give an introduction to DAFNI. So I'll start with a little bit, building on what Jim has just already said about why we want to build this platform, why are we doing DAFNI. So research in infrastructure systems, like other areas in academic research, is been massively changed by the use of computer simulation and increasingly data analytics and machine learning, and this gives us to explore how infrastructure is developed and how the impact of it on the environment and society. So this gives us a lot of technical challenges. As we get more and more data and our systems get more and more complex, we require better capabilities to handle that data and handle and provide more computer power to process it, and that gets quite challenging for a university department. There's maybe limited access to resource, maybe limited access to expertise in one place. So there is a significant this scaling up issue is really very significant, and beyond that we need to be able to also, in that added complexity, bring in data from lots of different places and share it and share data on different places and different locations, but also between different systems and different models. In a way, and we want to be able to do that in a way which respects security and in ways that that we can provide using common standards to do that, to mediate that exchange, and establishing that is very hard. And then we, as Jim already mentioned, we want to be able to integrate between models, capture those interdependencies. We want to be able to integrate across different sectors, so water, energy, land use, digital infrastructure. We want to be able to build models that look at the interactions between them, and also in the interaction between those things and the context, the environment, natural environment, and the economic and social environment in which we're living, and also across scales, from an individual item or piece of equipment right through to a location, to a town or a city or a region or a country. So we want to, those differences in scale, both spatially and temporally, again give us a whole load of other challenges. And if we're going to look at digital twins, which is an emerging areas, that brings a whole other aspect, another dimension of complexity to our systems, where we're connecting to sensors and real-time systems, which gives a lot more that extra level of computer complexity we need to support. So this produces real challenges for researchers in the research environment. And also we also need, so a way of kind of overcoming that is to give places for people to come together, and with people a place where people can share data and models, where they can support their collaboration. And as university projects may be, the funding may be short term, they might not only last 2-3 years. A place where we can then maintain things for the long term as a legacy, a place for creation. And this is what DAFNI is hoping to provide, this infrastructure for research, for the infrastructure research community, with a high performance hybrid computing platform as a basis, as a hardware basis to give that extra computing power, but on top of that, a dedicated software stack for a secure repository for data and models on infrastructure, and then that environment, that place to do research, to develop models, multi-system models, to develop new workflows and make them accessible to the users to explore their assets and systems in the short term, but also a place where we can go there, we can maintain those for the long term. So that's kind of what we're trying to do in DAFNI. What can we offer? How are we actually delivering that? Well, DAFNI is a program within the overall umbrella of the UCRIC program, the UK Collaboratorium for Research and Infrastructure in Cities. And within that program, it's an £8 million investment to provide a computing platform for that decision-making in national infrastructure, primarily to support research, but also to develop partnerships between academia, government, and industry. And the DAFNI is formed by a consortium of 12 partner universities, led by Jim Hall is the PI on this in the University of Oxford, and ourselves, STFC, the Scientific Computing Department, were brought in as development and hosting partners. We are a national research laboratory supporting the academic sector with long experience in supporting large-scale infrastructure to support research, including a lot of computing infrastructure, which is what our department specialises in. So, and what are we trying to do? Well, we're trying to do those aims I mentioned earlier with a hardware computing platform we put in place, and on top of that, we're building a software stack that gives us the functionality that we need. So we provide a login. So that's kind of an example. We've got a secure space where we can register users, and we can give them access in a controlled way to resources, respecting the licensing conditions of data or models as necessary. And then we can provide on top of that sort of support for uploading data and finding data to explore it and access it, and that's mediated by a data catalog, which gives a model of how to organize the data in the system. And then on that we have an environment for uploading models that people have developed elsewhere onto the system, and then build more complicated workflows around them, and execute them, linking them together as necessary, and then doing visualizations on those. That's one of the areas that's currently very much under development, and we hope to show some of the latest features of that today. So in that, and a couple of those things are a little bit more detail. We have DAFNI can provide a data hub with it's used a system called the NID, which is National Infrastructure Database. As a secure space or secure data repository, we can bring data together, organize it in a common metadata framework using a standard called DCAT to give us common search and access across that. And that gives us this platform, this information management framework, which is kind of a phrase that's come from the National Digital Twin Programme, as a way of integrating and combining data together. And this is an area we want to develop further, extending richer representation information from ontologies for different sectors in an ontological framework. So we've done some work in one of our champions programs, which I'll mention later, which is specifically exploring at how we might develop systems to support our ontology. And then we have the counterpart for modelling, the NIMS, the National Infrastructure Modelling Service, to support user models. So what the idea is, we can upload models from essentially more or less anywhere into our systems and into our model repository. And to do this, we use what's known as containerization, using quite a well-known piece of software called Docker. And this gives us a way of packaging people's code up into units or containers, which gives us a lot of independence from the underlying code, programming languages, libraries, operating systems, and it allows the models that are written independently to be brought together and executed on our platform without worrying about a lot of the niggly compatibility issues that always bedevil these kind of shared systems. So it gives us a way of uploading models, sharing models, and executing them, and then they're running on to our high-performance cluster using a system called Kubernetes to orchestrate them, access the data we hold in the NID in the same security model, and then execute them and produce visualizations. And then richer than that, we can then use the capabilities of the NIMs to chain them together into workflows, a couple of them, and we'll see examples of those later. So this kind of allows us to give some of these key challenges that come from the building this sort of integrated infrastructure ecosystem, coupling across different sectors, different scales, different scales. So that's a little bit about what DAFNI is and what it provides. How is it being used? Well, I'll just give a few examples of which we've been looking at over the last couple of years on using DAFNI. Firstly, a couple of examples where partners have brought models into DAFNI and uploaded them to the system, and we've done pilots with them. Firstly, here on the left is a model for the University of Southampton looking at station demand. So this is a model which looks at where you might place a new railway station, how that affects where the catchment of that railway station, where the passengers are going to come from and travel to that railway station. And so you might help decide where to put the best place to put a railway station. And then on the second one here is another model called SIMIM, which is looking at the changes of economic activity. This particular case in the Oxford-Cambridge corridor, resulting from changes in infrastructure, how that changes the economic activity and the gross value added of that area. So these are examples of where we brought existing models onto the platform and run them and allow them to kind of make them accessible and also scale them up. NISMOD has been a very major example of ours. I won't mention this any further because we'll talk about all that later, but it's been a real major example of what we've been trying to do. But I will mention the next step on from NISMOD we're trying, which is a relatively new project we're starting called OpenClim, which is called the Open Climate Impact Framework, a new project by the University of St Anglia, started a few months ago. And this is looking at the risk of climate change, things like flooding, heat stress caused by extreme heat events, the effects on agriculture and biodiversity, and also what are the risks that's caused by climate change to those, but also how we might mitigate them by adapting the environment to accommodate or cope with them. And this is work that's kind of been motivated by the upcoming climate change risk assessment, which I think it takes place in 2026. So we're kind of doing research work to prepare for that. And it takes this multi-systems approach. So we were looking at workflows. This is a workflow. Don't expect you to go through this, but it looks at the effects. So here we have some climate change data coming in here that affects our various vegetation models and things. And then up here we have some urban development model, and then we're combining those data together into flood models to explore what the flood risks are. So it's a multi-systems approach, and we're working with the Climate Change Commission and DEFRA as end user partners here as well. And what DAFNI is going to be doing there is providing a framework to combine models together, a place where users can go and access and run models, including people like the Climate Change Commission, and also a legacy where after the end of the project, the models can reside and as well as workflows can continue to be accessed. And finally, an example, which is we're beginning to explore in sort of digital twin space. This is an example for one of our champions, Christian Jeans at the University of Sheffield. And this is looking at traffic data, live traffic data from the Urban Observatory in Sheffield, which has a load of sensors around the city looking at traffic flows. And what Christian has done is build an AI-based model which takes up real-time updates on that and predicts the evolution of the traffic over in the next 30 minutes. And then you could potentially feed back to the traffic control systems to adjust the traffic lights or whatever. And what we're doing is we're bringing this onto the platform and seeing what we need to do to DAFNI to adapt that real-time control, and that's looking very promising at the moment. So that's some examples, and just to summarize, so that kind of concludes what I was going to say. So to summarize what we have, well, in DAFNI we have a search of our environment for a research collaboration for National Digital Twin, but also for also wider for the research community, infrastructure research community, and a place where we can do research, but we can also bring in present things to in collaboration with our government agencies and with industry to explore new ideas and models. So that shared collaboration space where we offer a HTC platform supporting that research and technology transfer. We have data sharing within common information infrastructure. We can scale and couple models and provide a place for long-term legacy to access those models. Still a lot of work to be done. We're exploring digital twin pilots and how that might affect. We still want to do a lot more with our data management framework. We've got work to do on visualization, which is very much ongoing at the moment. We want to be able to do increase the work, capability to support our data ontology, as I've already mentioned. But nevertheless, we have the basis, it is up there and working, and I'll explain a little bit more later about how to actually access, get onto the platform and try things out. Okay, so I think that's more or less all I had to say at this stage. So thanks very much for listening.
Thank you, Brian.